Welcome to the Analog Communication Engineering playlist. Here in this session, I will be going to explain you the power calculation, the efficiency calculation, the spectrum, the phasor, the bandwidth, and also the advantage and disadvantage of DSBSC signal. Therefore, in this session, I will first explain you the mathematical derivation of power and efficiency calculation for DSBSC signal. Then I will explain you the spectrum and phasor diagram of DSBSC signal. And lastly, I will also explain you the bandwidth and advantage and disadvantage of DSBSC signal. So let us begin this session with the power calculation of DSBSC signal. Now we already know the DSBSC AM signal waveform mathematical expression, and I also explain you the mathematical derivation of the DSBFC power calculation and efficiency calculation, where we have seen that the maximum power efficiency for DSB-SCAM signal we can achieve, that is 33.33%. If you want to know how we can determine the DSB-SCAM power signal, please go through my previous video. So this is the DSBFC AM signal, that is AC 1 plus mu cos 2 pi FMT and cos 2 pi FCT. This is my carrier signal, this is my AM signal, and we will get this mathematical equation of conventional AM signal or DSBFC AM signal. How we can determine this signal, you can go through my previous lecture. Now we also know that DSBSC modulated AM wave, okay, that is nothing but the multiplication of message signal and carrier signal, AMAC cos 2 pi FMT and cos 2 pi FCT. So if we simplify this equation, we will get AMAC cos 2 pi FC plus FMT and AMAC cos 2 pi FC minus FMT. That means only USB and LSB will remain in DSBSC signal and carrier is suppressed. Already I have explained the generation of DSBSC signal using the ring modulator and valence modulator, as well as I will explain the AM signal generation using switching modulator and coil law modulator. So if you want to know, please go through my previous video. This thing already I have explained to you, right? So now we intend to determine the DSBSC power calculation, because we need to, if we want to design, the main important thing, we need to determine the power consumption. So as we know that to determine the carrier power, so we can determine it, PC is equal to VC by root 2 whole square by R, where PC is the carrier power, VC we assume the peak carrier voltage, VC by root 2 is nothing but the RMS voltage we all know, and R is the load resistance or antenna ohm. Okay, so PC will be VC square by 2R. Similarly, we can determine the lower sideband or upper sideband power, and already we know that the power consumption or requirement for lower sideband upper sideband is exactly equal. So it will be MVC by 2 whole square by 2R. So PLSB is equal to PUSB will be MA square VC square by 8R. We can also rearrange this equation with MA square by 4 PC, because VC square by 2R already we know it is nothing but PC. So we directly replace this VC square by 2R with PC. So this equation MA square VC square by 8R will rearrange with MA square by 4 into PC. So this is the individual power of each sideband, and this is the total power of individual power of requirement of carrier signal. Okay, so now if we want to determine the conventional AM or DSBSC AM, then we know that this DSBSC AM or conventional AM signal consists of three frequency components, that is P carrier, P USB and P LSB. So we will get this mathematical equation, that is PC PT is equal to total power of DSBFC or conventional AM will be PC into 1 plus M square by 2. I already explained this mathematical derivation in my previous video, where I explained how can we determine the total power and efficiency of DSBSC AM signal. Here I directly write the formula. If you want to know the steps, you just go through my previous video as I mentioned you before. Now, the total transmitted power of DSBSC signal. Now, to determine the total power requirement of DSBSC signal, we know it contains DSBSC signal consists of only two frequency components, that is USB and LSB. Carrier is suppressed, so there is no requirement of carrier power. So it is simply the total power of DSBSC signal is simply the addition of lower sideband and upper sideband power. So if we add, we will get MA square PC by 2. Okay, so it will MA square by 8R, M square by 8R. If we determine MA square DC square by 4R, and if we replace it with carrier power, then we already know that DC square by 2R is nothing but my carrier power, so it will rearrange with MA square PC by 2. So total power or DSBSC signal, you remember, that is MA square PC by 2, and total power of DSBSC or conventional AM signal, that is PC into 1 plus MA square by 2. Now we intend to determine the efficiency. So efficiency is nothing but what much power for DSBSC signal we save. So that is nothing but total power minus PT dash, that is DSBSC power, by total power. So if we put it the formulas and if we simplify it, we will finally get that power saving will be 2 by 2 plus MA square into 100%, because it is percentage of saving. So now for the maximum power efficiency, we know that only can achieve if we will get 100% modulation. 100% modulation means where modulation index value will be 1. So if we consider MA is equal to 1, then power saving will be 2/3 of the 100, that means 66.7%. So therefore the power requirement, or you can say the power efficiency of DSBSC signal is 66.7%. Okay, so in this manner we can determine the total power of DSBSC signal, as well as we can determine the power efficiency of DSBSC AM signal. Now this is the DSBSC time domain signal. Already we know how to, it is nothing but look like this, and at the V minimum 0 there will be the phase change. This is the most important thing, already I have told you. Okay, so remember this time domain signal. Now if we plot the frequency spectrum of DSBSC signal, the AM signal is FM and minus FM. The frequency spectrum of carrier signal will be this, and DSBSC signal carrier spectrum signal will be this. Only LSB and USB will remain with its amplitude AM AC by 4, where carrier signal FC is in dotted manner because it is suppressed. So always we remember, when you plot the spectrum of DSBSC signal, you need to draw the carrier signal with dotted line, because it only consists of two frequency components, that is LSB and USB. Now this is the phasor diagram of DSBSC signal. Okay, now here USB is FC plus FM and LSB is FC minus FM. Now always remember, this LSB and USB are equal magnitude and rotate in opposite direction. Okay, not the similar direction, in opposite direction. So it is plus omega m, it is minus omega m. Okay, now upper sideband, a phasor rotating counterclockwise. USB will be rotating counterclockwise, remember, where the modulating signal is omega m, and LSB will be rotating with clockwise, where modulating signal will be minus omega m. Okay, so this is the upper sideband or lower sideband, and resulting phasor will be the the summation of the two vector, that is this is the phase logs are the combination of vertical components of, we cancel out this and leaving the resultant along the carrier signal. Okay, so this is the resultant output, this is the resultant, where with this dotted line we equivalent circuit, and this is the resultant output which is equivalent to the horizontal axis. Now remember, this modulating signal cross the zero when this is the time domain signal. This when modulating signal here this cross the zero, the resultant phasor undergoes the instantaneous 180-degree phase shift. This is the difference with the conventional AM with DSBSC signal. Remember, this is the most important thing. When modulating signal cross the zero, the resultant phasor, that means this, will undergoes instantaneous 180-degree phase shift. So this is all about DSBSC AM phasor diagram. If you need to draw it in exam, you need to draw it and write these points. This is enough to accrue the full marks. Okay. Now the bandwidth. So bandwidth, we will know the bandwidth formula is nothing but the differentiate between the F max and F min. It is the difference between F max and F min. So the F max here for DSBC signal is Fc plus Fm, and the F minimum is Fc minus Fm. So bandwidth will be Fc plus Fm minus Fc minus Fm difference. So bandwidth will become, we will get 2Fm. Thus the bandwidth of DSBSC AM signal is the same, that is that of DSBSC signal. So it is equivalent to the twice of the maximum modulating voltage. So therefore the disadvantage and advantage of DSBSC AM we can summarize in this manner, that the advantage of DSBSC signal is compared to the DSBFC or conventional AM signal, the power efficiency will increase, that is 66.7%, which is in DSB signal we will determine that is 33.33%. Already we will determine both the derivation, so it is clearly visible that power efficiency will increase in DSBSC AM signal. But disadvantage is, although we suppress the carrier signal, but there is no improvement in bandwidth in DSBSC signal AM signal compared to the conventional AM or DSBSC AM signal. So the advantage is the power efficiency increase, but disadvantage is the bandwidth requirement will remain same as conventional AM or DSBSC AM. So this is all about the advantage disadvantage of DSBSC signal, the bandwidth determination of DSBSC signal, the phasor diagram and explanation of DSBSC signal, the frequency spectrum and explanation of DSBSC AM signal, the time domain signal where phase reversal is very much important of DSBSC signal is also discussed. The power efficiency determination of DSBSC AM signal has been discussed, and also the power calculation of DSBSC AM signal has been discussed in this session. So thank you so much for watching this video. You can give your valuable suggestion and queries regarding what is required here in analog communication engineering. Definitely I will be get back to you based on your queries. So stay with this channel and keep motivating your friends. Thank you once again for watching this video. May the God watch over you. Thank you.